Good evening, one and all. This is lecture number 23 in electric vehicle. So this module 4th is actually electric vehicle. This is the course electric and hybrid vehicle P3 180C656. So we had started this module yesterday. We have seen the basics of electric vehicle, the evolution. Today we are going to see the tractive effort and transmission on and vehicle performance of electric vehicle. This is 2nd June 2023. So around 4 to 5 lectures more will be required to complete this module, and we are going to see electric vehicle as well as hybrid vehicle in this module. So this module 4 is actually divided into two parts, electric vehicle as well as hybrid vehicle. This is the first part, that is electric vehicle. In that yesterday we have seen configurations of EV, performance of EV, and under performance there are mainly three topics. Traction motor characteristic we have seen yesterday. Today also we are going to see a glimpse of it. So mainly today you are going to see tractive effort and transmission requirement and vehicle performance. So we have seen the same parameters in case of IC engine based vehicle. There will be slight change in the formula for electric vehicle. We are going to see that, though we are not going to go for derivation of those things. We know all the performance parameters already. Only in electric vehicle whatever are slight changes that we are going to see in today's lecture. Two more topics, that is tractive effort and in normal driving and energy consumption in electric vehicle, calculation of that. It will be covered in next lecture, that is lecture number 24, and that will complete the electric vehicle discussion as per our syllabus. Then we are going to see electric and hybrid vehicle. Electric vehicles, module number 5, Ehsani, starting from page number 95. We can find all this discussion whatever I am going to do today. It will be available in the book of Ehsani from page number 95. So this slide is known to us, yesterday we have seen. So whenever an electric vehicle is driven, in this tractive effort developed by a traction motor on driven wheels, it is given by function Ft. F stands for force, this is a linear force. T stands for traction, that means this is the force which takes the vehicle forward. Tm is nothing but the torque, motor torque, which is generated by the motor. Ig and I0, so Ig is the gear ratio of the transmission, I0 is the gear ratio at the final drive. A good amount of discussion was done about final drive element in the differential. So in the module number 1 we have seen that. Eta T is the efficiency of the whole drive line from the motor to the wheels. Rd is called as the actual radius, effective radius of the driven wheels. So all these formulas were seen yesterday in tractive effort and transmission. So when we are going for the next topic, then also all these basic formulas will be required. Another formula, important formula of V, that is the linear velocity, is a function of speed of the machine, that is speed of the motor, and pi Rd, 30, Ig, I0, all these are actually constants. 30 is the pi and 30 are the empirical formula constants, and Rd is effective radius of the tire, this is a system constant. Ig, I0 are also the system constant. So this is in meter per second. If you want it to be converted to kilometer per hour, we have to multiply this thing by 3600 and divide this thing by 10,000, sorry 1000. Okay, so the whole thing will be multiplied by 3600, that is 60 into 60, and it has to be divided by 1000. That means actually the whole thing has to be multiplied with 3.6, then we are going to get kilometer per hour. So the use of a multi-gear or single gear transmission depends on mostly the motor speed torque characteristic. So yesterday I have shown you one very important factor which is called as the speed ratio. It is actually the ratio of maximum output speed divided by the base speed. So lower is the base speed, we have found that the gear ratio or the value of x is actually high. In that case we can get higher starting torque for base speed to be small. and as you are increasing the value of x, that is the speed ratio, then we are finding that base speed is increasing, and the ratio of maximum speed by base speed, that value actually will decrease. So lower the speed ratio means it is for the higher gear. So lower the speed ratio, initial torque will be less, base speed will be more. So at a given rated motor power, if the motor has a long constant power region, single gear transmission will be sufficient for a high tractive effort at low speeds. So this kind of relationships you have to remember, that at a given rated motor power, if the motor has a long constant power region actually starts after the constant torque region. So constant torque region finishes, then the torque starts reducing, speed starts increasing, that is actually called as a constant power region when the speed increases. So whenever we are in the second region, that is constant power region, where the torque decreases or speed increases. So for that long constant power region, single gear transmission would be sufficient for a high tractive effort at low speeds. Otherwise, a multi-gear or more than 2 gear transmission has to be used. So now I'm going to show you 3 slides, and this characteristics actually we have seen previously, but here we are going to go into a more elaborate study. So here we are finding that this is figure shows that tractive effort on EV along with the vehicle speed. Here actually the x value is equal to 2, that is the speed ratio is 2, because here we are finding maximum speed of the vehicle as 100. Now one thing I would like to remind you, that this is not the motor speed, this is the vehicle speed. Okay, so I told you yesterday we are finding maximum motor speed as 5000, so that 5000 motor speed corresponds to 200 km per hour vehicle speed. So that is a scale you can find out. So 200 km per hour vehicle speed or 5000 rpm motor speed, both are same. So there also you could find speed ratio, here also you can find speed ratio, because there we are saying that at this point for very high value of speed, base speed, we were taking this thing to be around 2500. The base speed for very high gear or third gear, it was around 2500. That was rpm, that was the motor speed. Now here instead of 2500 we are calling it to be vehicle speed to be 100. So what we find here is x is equal to 2. How x is equal to 2? Maximum speed 200, base speed 100, because we are mainly talking about this GFH. So this is GF and this point is actually not there. So this is GFH, I'm sorry, not the vertically down. GFH is the actually the highest gear torque or effort, or tractive effort versus speed characteristic. So you are finding y-axis is tractive effort in kilonewton, x-axis is vehicle speed. GFH, this is the speed for characteristic for which characteristic? Tractive effort versus vehicle speed characteristic for third gear system. So here it is written in the book of Asani, it is given a little wrong, this nomenclature, so you can prepare it from the slide only. It is GFH. So GFH, this characteristic is actually defined by this, whatever graph is shown, this is actually defined by the highest gear. Highest gear is nothing but third gear, GFH, or highest this effective ratio, this is speed ratio, which is called as x is equal to 2. So as soon as it is x is equal to 2, you have to understand that we are talking about a higher gear. Whenever the initial base speed was very low, at that time speed ratio was 6. So we are going to see 3 cases. Here motor speed ratio is 2. What is speed ratio? It is nothing but the highest speed divided by maximum base speed of highest gear. So that's why it is called as VB 100. So 200 by 100, this is x is equal to 2. In this case we are finding that initial speed, initial torque will be less, and speed range is quite high, we are finding. And there is another graph which is starting from 0 and increasing in a faster rate and is going high. It is called as a constant power, it is called as a rolling resistance and aerodynamic drag. So you are finding that as speed increases, aerodynamic drag also it increases. And H, you are finding this is the calculated position of the maximum speed And in this case what we are finding is at this point rolling resistance, aerodynamic drag, that also is increasing. So this is another thing you have to understand from this graph which is shown at the below. This is the loss curve. So at very low base speed or at very low vehicle speed, you are finding that this loss is less, because one thing you have to understand that this aerodynamic drag, it increases with the velocity. So more is the velocity, more will be aerodynamic drag. So here you are finding that at this point vehicle speed is very high, around 190 km per hour. Rolling resistance is also increasing, aerodynamic drag is also increasing. But nevertheless, vehicle is at higher speed, and while estimating the efficiency, this slide will be important. So this characteristic also you have to explain while you are explaining this graph. So what all things we can find out here? So this part actually, this is the difference where this gear, that is the third gear, constant torque extreme point towards the right side, this is point F. Here actually we are calculating how much is the net tractive effort. So Ft is the tractive force. Net tractive effort means actual tractive force generated by the vehicle minus the Fr and Fw. So aerodynamic rolling resistance loss and windage loss, if you subtract it from tractive effort, if you can say that there is a net tractive effort which is driving the vehicle. So these are smaller things. Now you are matured enough in this topic, now you should understand. And this loss is actually increasing when the speed of the vehicle is increasing. So many things I have written here. Whenever you are writing this thing in the exam, try to label these graphs as much as possible. So there are two lower gears also. So this is the second gear, DEF. So DEF, this is the second gear. This is having initial starting torque as 4.5 kilonewton. Lowest torque, that is the lowest gear, that is the first gear. This is around 6.5 kilonewton, and this is given by ABC. And ABC does not stop at C, it keeps on going. So whenever it comes to DEF is the characteristic, then speed increases, it goes to GFH likewise. So while explaining, you have to start explaining from ABC. This is the highest output torque, initial torque, and first gear. Then DEF, this is 4.5 kilonewton, medium starting torque, second gear. And whenever the vehicle goes into third gear, torque decreases and speed increases. And you are finding this is the VB for the first gear. VB for the second gear is not shown, it will come around 45 or 50 km per hour. Third gear is having base speed of VB is equal to 100 km per hour. And this characteristic is actually defined by the name of highest gear base speed, that will be highest base speed, that is 100 km per hour. What all things are written here? The first gear covers the speed region ABC, second gear covers DEF, and third gear covers GFH. All these things are shown. So there are little printing mistakes in book of Ehsani, be careful. X is called the speed ratio for a particular gear. Higher is the base speed of the gear, lower is the speed ratio. So this is not the case actually for EV. EV generally having only one gear. So in that case we will find that X will be equal to 6 in that case. So the third case that I am going to show here will be the case for generally EV. But okay, EVs might have more number of gears. You have seen yesterday we have shown you 6 different configurations. In the first configuration, where IC engine based vehicle, IC engine was removed and it was substituted by a motor. In that case you found there was a clutch, there was a gear changing mechanism as well. So that EV was actually having more than one gear. So after this we are going for the next case where number of gear actually reducing. So here you are finding there are 2 gears. So higher gear is second gear, and this is having base speed of around 45. So maximum speed is 200 and base speed is around 45 to 50, you can say. So 200 by 50 around, though I have written 45, if you consider it 50 it will be better. So 200 by 50 it will be around X is equal to 4. And you are finding that whenever this kind of situation is there, here for the second gear initial torque is 4.5 kilonewton, and for first gear, which is having base speed of around 30 km per hour, initial torque is around 6.5 kilonewton. So here it is 4.5 kilonewton torque, here it is 6.5 kilonewton torque, here the base speed is around 50, here the base speed is around 30. Same kind of characteristic you are finding at high speed around 100 km per hour. You are finding that Ft minus Fr minus Fw. This is nothing but the net tractive force, and this is actually the torque reduction curve. So whenever the torque has started reducing, this is actually the constant power curve. So here torque is reducing, speed is increasing, you can find, because speed is there in the x-axis. Maximum speed is same, around 190 to 200. So a little bit of discrepancy is there. You can say 200, or if you are taking 190 or 180, it will be exactly 180 by 45, x is 4. Those little bit of discrepancy you can understand, I think. So this region after this point B or after this point E, this will be a constant speed region. Sorry, constant power region. I'm sorry, not constant speed. Speed will be increasing. It will be called as a constant power region. In this case, the torque will be reducing. So in this case, you are finding initial constant torque is of 6.5 kilonewton in the A, B, C range. So this is A, B, C. Second situation, that is DEF. In this case, this will be the second gear, and you are finding there are only two gears here. Motor speed ratio is x is equal to 4. How this x is equal to 4 is calculated? It is around 190 or 200 by 45 or 50. So roughly it comes to the value of 4. This is tractive effort versus vehicle speed with a traction motor x is equal to 4. It is a 2-gear transmission, whereas in the previous case you found x is equal to 2. It's a 3-gear transmission, and x is always calculated for the base speed of the highest gear. So this is the base speed of the highest gear, it is 100. That's why x is equal to 200 by 100 is equal to 2. In this case, base speed highest of highest gear is around 45 to 50. Highest speed is 200, so 200 by 50, x is equal to 4. So the first gear covers the speed region ABC, you are finding here. Second gear covers the speed range of DEF. Constant torque region, constant power region, all those things are shown. Rolling resistance, aerodynamic drag, it also keeps on increasing with respect to the base speed. Constant power and speed increases. So that happens after B or after E. Last one, which is most closest to the actual EV which are coming in the market now. This is a single gear transmission. You are finding base speed is around 30. Maximum initial constant torque region, we are finding it to be very narrow, but very high starting torque is produced, around 6.5 kilonewton. So here you are finding that speed is around 180 to 190, a maximum speed, and base speed for only one gear is 30. So 190 by 30, it is around 6 point something. We are taking it as a 6. So these three designs, that means x is equal to 6, x is equal to 4, x is equal to 2. These three designs have the same tractive effort versus vehicle speed profiles. Therefore, the vehicles will have the same acceleration and gradability performance. That means whenever you are in x is equal to 4, you are finding that its initial gear is same as the initial gear of this single gear system. So that's what they are saying, that initial gear performance for x is equal to 2, x is equal to 4, x is equal to 6, all are same. But whenever it is x is equal to 2, you are finding that it is having more gear features. So we can have different kind of multi-speed transmission here. But whenever it is single gear, that is x is equal to 6 transmission, we don't have the problem of changing gears and all those things. The vehicle will be run on only one gear. So characteristics are of similar type. So this three cases can be asked in the exam: x is equal to 6, x is equal to 4 and 2. You have to draw all these three characteristics and explain in detail. So this is tractive effort versus transmission requirement. This was the second performance in EV, that is electric vehicle performance. This was the second type of performance. Third performance, vehicle performance. This is the third performance characteristic, which is called as a vehicle performance. Under this there are some few parameters. So what are the basic vehicle performance parameters? There are mainly three: cruising speed, gradability and acceleration. For IC engine based vehicle also we have seen it was same thing. Speed, here we are calling it cruising speed, gradability and acceleration. So speed means maximum speed of a vehicle can be easily found by the intersection point of the tractive effort curve with the resistance curve. Rolling resistance plus aerodynamic drag. Here we are not talking about the grade resistance. That means we are assuming that vehicle is going on a flat road, so we are not assuming the slope here. In the tractive effort versus vehicle speed diagram shown in the previous three figures, we could very easily found out the maximum speed. So you can check here. Here the maximum speed is where this tractive effort graph, this is crossing this loss line. Okay, so this point, that is point C in this thing, this intersection point, this is actually maximum speed. So we can take it around 180, 190 or around 200. But to be very precise, this is actually around 190, right? So this is how the maximum vehicle speed is calculated. So what is the maximum vehicle speed? Where the Ft minus Fr minus Fw line, it crosses the reducing torque line. So this point is the maximum vehicle speed point. So maximum vehicle speed of a vehicle can be easily found by the intersection point of the tractive effort curve. Tractive effort curve is falling from the top to the bottom with the resistance curve, rolling resistance plus aerodynamic drag. In the tractive effort versus vehicle speed diagram shown in the previous three figures, such an intersection point does not exist in some designs. Usually whenever there is a large traction motor or large gear ratio, in that case we don't find this kind of intersection very precisely. So in this case, the maximum vehicle speed is determined by the maximum speed of the traction motor as. So what is the maximum speed formula? It is pi nm max into rd divided by 30 ig min into I0. So gear ratio is in our hand, we can change it depending on the vehicle, and the rotational speed, it actually varies as per the gear and as per the losses. So previously we had found V was equal to pi into nm into rd divided by 30 ig into I0. So in that, I0, rd, 30 and pi, they are absolutely constant, they cannot be changed. So what we can change is the rotation of the motor, that is n in rpm, that we can change, and we can change what is called as a ig. Ig is the gear ratio of the vehicle. So if it is multi-speed transmission, ig can be changed. If it is single gear transmission, in that case ig is fixed. So ig can be changed only in case of multi-gear transmission. So whenever we are trying to find out V max from V, we have to maximize the numerator and minimize the denominator. So whatever is the maximum speed of n, that is called as nm max, there you can calculate what is called as a V max. At the same time, at the ig should be min, so nm max by ig min, dividing that, and you are multiplying pi rd at the numerator, 30 and I0 at the denominator, you are finding the same thing called as a V max. So from V, how to get V max? Speed of the motor should be maximized and gear ratio should be minimized. So this is a unit in meter per second. If you want to convert this thing into kilometer per hour, again the same thing, you have to multiply the numerator with 3600 and divide the whole thing by 1000. So dividing by 1000 will take into kilometer, and multiplying by 3600 seconds will take it into hour. So it will be kilometer per hour if you multiply this whole thing by 3.6. So here nm max is allowed maximum rpm of the traction motor, ig min is the minimum gear rate ratio of the transmission for highest gear. So this is the first parameter, which is called as a cruising speed or maximum cruising speed or maximum vehicle speed. Gradability is determined by the net tractive effort of the vehicle. So Ft net is equal to Ft minus Fr minus Fw. So it was shown in the previous diagram. So this is actually called as a Ft net. Ft net is Ft minus Fr minus Fw. Ft is the total tractive effort produced by the power source of the vehicle. Fr is the rolling resistance, Fw is the windage resistance. So Ft minus Fr minus Fw will be F net. That thing is calculated first while finding the gradability. So it's determined by the net tractive effort of the vehicle, Ft net, as shown in the previous three figures. At mid and high speeds, the gradability is smaller. That means whenever you are at mid speed and high speed, that means second gear or third gear, you will not be able to climb hill. So for hill climbing, we have to keep the vehicle at the lower gear. That means only first gear can be used for hill climbing. Maximum grade that the vehicle can overcome at the given speed can be calculated by. So what is I? If you remember, I was equal to h by L, that was tan alpha. How can you calculate that tan alpha or I, that is the angle, maximum angle that can be ridden or that can be overcome by the vehicle at the given speed, at any given speed? It is given by Ft net divided by m into g. M is the mass of the vehicle, g is the gravitational constant, is equal to Ft minus Fr plus Fw. So Fr plus Fw is the loss, Ft is the net, sorry, actual tractive force generated. So all the numerators are in this is unit of force. Force is nothing but Newton, divided by mg, mass into gravitational constant. So this ratio, that is what is the Ft net. Ft net is Ft minus Fr plus Fw divided by mg, mass, which is always trying to pull the vehicle down. This ratio is called as I, which is nothing but gradability, or how much maximum angle the vehicle can overcome. So Ft is the tractive effort of the driven wheels, Fr is the tire rolling resistance, Fw is aerodynamic drag, and Fw is directly proportional to the vehicle speed. Another thing you have to remember. However, at low speeds the gradability is much higher. That means whenever the vehicle is kept at a lower speed, at that time it can ride better on the hill, because speed is less means torque is more, because power is constant if we assume. So whenever the speed is less, torque is more, at that time we can have a better riding performance on the hill. So this is what they are saying. However, at low speed gradability is much larger. Next is vehicle performance. So gradability we can calculate in other way, sin alpha. So alpha is equal to sin alpha for very less value of alpha. This is equal to d minus fr. So this formula we have seen previously. Root under of 1 minus d square plus fr square. So fr is the rolling resistance. D is equal to Ft minus Fw by mg. So you should not confuse. Previous case I was equal to Ft minus Fr plus Fw by mg, but in this case we are having a special parameter which is called as a D. It is called as a vehicle performance factor. It is Ft minus Fw. We are not taking Fr in this case. So Ft minus Fw, that is tractive force generated minus windage loss divided by mass into gravitational constant. This is called as a D. So if you are trying to find out the sign of the gradability, and sin alpha is equal to alpha for alpha small, in that case sin alpha is equal to, so if we know sin alpha, we can take the sin inverse and we can find out alpha. So even for bigger gradability also this formula can be used. For smaller gradability, sin alpha is equal to alpha. So if the gradability is more, in that case sin alpha you have to use. How to calculate that? From vehicle parameters, d minus fr root under of 1 minus d square plus fr square divided by 1 plus fr square. So fr you know is the tire rolling resistance, d you know what is d, Ft minus Fw by mg, and there are no other parameters. So only two parameters are there, d and fr. Both things are explained. Third parameter is acceleration. So performance of the vehicle is evaluated by the time used to accelerate a vehicle from 0 speed up to 100 km per hour speed for a passenger car. So this is the definition of TA, or acceleration time. So time taken by the vehicle to accelerate its speed from 0 to 100 km per hour. For such cars the performance is more important than maximum cruising speed and gradability. So for some vehicles, how better it can accelerate, that characteristic is very important, since it is the acceleration requirement rather than the maximum cruising speed or the gradability that dictate the power rating of the motor drive. So for some vehicles we are not checking how much is the maximum speed or how much grade it can climb, that means its performance on the hill, but how good pickup it can give. So the way we can talk pickup, that means how fast it can increase its speed from 0 to 100 km per hour. So this time is called as acceleration time. So acceleration time can be called as delta. So this was a constant of conversion of rotational speed into linear speed. M is the mass, 2 into pt. Pt is the actual tractive power, Vf square plus Vv square. Vf is the vehicle speed, actual speed, final acceleration speed it is called as, and Vb is the base speed. So this is a very important formula you should remember, that is Ta is equal to delta into m by 2 pt. Pt is the tractive power on the driven wheels transmitted from the traction motor corresponding the vehicle base speed. Delta is the vehicle rotational inertia constant. So how many parameters? 1, 2, 3, 4, 5 parameters. Delta is the vehicle rotational inertia constant. PT is the total tractive power of the vehicle. Power is given in watts, or you can give it in kilowatts. M is the mass of the vehicle. VF is the final acceleration speed, and VB is the base speed. PT is equal to delta M by 2 TA VF square plus VB square. So you can calculate roughly what is the this is a rough formula. Fair or very good correct formula will be given in the next slide. So roughly you can calculate tractive power of the vehicle in terms of final speed element and base speed element in terms of mass and acceleration time. So if time is given, we can calculate power. If power is given, we can calculate acceleration time. So PT is equal to delta M by 2T VF square plus VB square. So the power rating obtained from PT equation is only the power consumed for vehicle acceleration. So this you have to understand, that this power is only for vehicle acceleration. To accurately determine the tractive power rating, the power consumed in the overcoming the rolling resistance and dynamic drag also should be considered. So you can find here that aerodynamic drag is not considered here. You can find here that the rolling resistance is not considered here. So only we have considered VF and VB. Okay, and that way we are calculating how much is the probable PT, that is the tractive power. But if we are taking all the parameters into consideration, so these slides are very important. You can find out that vehicle performance, also there are 2 stars put here. Okay, vehicle performance. So whole thing you can explain gradually exactly the way it is given. So sin alpha, alpha, a TA equation, PT rough equation, PT correct equation. So this is the PT correct equation. We have seen the same kind of equation in IC engine based vehicle also. So what we are finding is the total tractive power for acceleration the vehicle from 0 speed to 100 km per hour speed can be obtained by delta M by 2 TA VF square plus VB square. So previously only this was the formula, PT is equal to delta into M by 2 a VF square plus VB square. We had ignored these 2 losses. Okay, so though these 2 losses are comparatively small than this delta M 2 TA VF square plus VB square, so there is only the tractive power. But net tractive power, you should actually you are overcoming these 2 losses. The first one loss is rolling resistance, and second one is the aerodynamic drag coefficient. So these 2 losses are overcome, and then only net tractive power is produced. So that's why these 2 losses are also added in the total power generated by the vehicle. So this is one thing you have to observe, that is correct equation of PT, that is actual tractive power, is whatever is the power for generating the acceleration and whatever power are there which actually has to be overcome, which is nothing but the rolling resistance power and aerodynamic drag power. And here another thing you can check, that whenever you are talking about rolling resistance, in case of IC engine based vehicle it was mgfr/vf. In this case there is coming a coefficient, that is 0.672 by 3. This is the rolling resistance, and here also in case of aerodynamic drag there is coming a coefficient of 0.2 or 1 by 5. So this is the change in the equation of PT in case of IC engine based vehicle and the PT in case of electric vehicle. So whenever we are talking about PT of electric vehicle, at that time these 2 factors 2 by 3 and 1 by 5 has to be incorporated with rolling resistance and aerodynamic drag. So be careful. Above equation indicates that for a given acceleration performance, low vehicle base speed will result in a smaller motor power rating. So whenever we are using a low vehicle base speed means base speed is smaller, that means it is having very high starting torque, but the constant torque region is narrow. Okay, constant power region will be more, so it will also generate highest speed ratio of X. So whenever you are finding that for a given acceleration performance, low vehicle base speed, that means base speed is equal to 30, we have seen maximum speed was around 180 190, we were having a speed ratio X of 6. Differentiating this equation with respect to base speed VB, we can obtain the decline rate of power. So how the power will reduce with respect to the base speed. So this is called as a decline rate of power, dPT dVB. VB is nothing but the base speed. With respect to base speed, what will be the relationship of net tractive power? So this is delta into mv divided by Ta into Vb. So delta is nothing but that constant, mv is nothing but the mass of the vehicle, Ta is the acceleration time, and Vb is the base speed. So here you are finding that there is a very important graph, and this graph may be asked in the exam. You have to write it clearly. So here x-axis is x. X-axis is x means nothing but the speed ratio. And I would like to have your attention here. That is towards the right side you are finding this is value of x is more. Value of x is more means this is lower gear. So whenever the gear is low, that means gear is low means its base speed is low. Base speed is low means around 30. Highest speed is around 180 or 200 if you can say. So 200 by 30 means around 6. So here you are finding base speed gear ratio x is equal to 10. That means base speed is 10 times lesser than the maximum speed. What is base speed? Base speed is the region till which initially the torque is constant. So whenever I am saying x is equal to 10 means base speed is 10 times less than maximum vehicle speed. On the contrary, in the left side you are finding x is equal to 2. X is equal to 2 means base speed is only half of the maximum speed. Okay, so this is higher gears. Higher gears means base speed is more. Constant speed is already constant at the maximum side. So that is 200. Base speed is 100. So 200 by 100, gear ratio is 2. Okay, so here you can say gear ratio is 10. That means base speed is 20. So here base speed is 20 km per hour. Here base speed is 100 km per hour. So this you have to understand. That means left side it is showing higher gear, right side it is showing lower gear. And you can check these two characteristics. Very important. It is a little difficult to understand, but I'd like to have your attention. Here the ratings of the vehicle is given. Ta is 10 seconds. That means within 10 seconds 1200 or 1200 kg vehicle, it accelerates from 0 up to 100 km per hour. Okay, so rolling resistance is 0.01. CD and AF, they both are aerodynamic coefficients. It is 0.3 and 2. Rolling resistance is 0.01, so quite a smooth road. So within 10 seconds the vehicle reaches from 0 km per hour to 100 km per hour. So higher the base speed for higher gears. So base speed is high means gear is high. Lower will be the value of x. You can find here in 2. So x is 2 means base speed is high. So 200 is the highest speed and 100 is the base speed. So ratio is 2. High speed ratio x means lower gear. So in this case x is equal to 10. That means base speed is 20. Maximum speed is 200. So 200 by 20 is 10. So high speed ratio x means lower gear. So in the above diagram, speed ratio 10 occurs for the lowest gear, high torque. Speed ratio 2 occurs at the highest gear, low torque. X cannot be 0 or negative because x is just a ratio of two positive numbers, that is maximum speed divided by base speed. So it cannot be negative. For higher gears, tractive power rate change is higher. So you are finding for higher gears, that means in the lower side, delta P divided by delta VB. That means with respect to base speed, how the output power is changing. Okay, it ratio is changing very fast. You are finding that this graph is flatter or very flat towards the right side. Towards the right side means here the x value is very high. X value is very high means you are talking about lower gear. So this characteristics, so there are two things. One is called as a tractive power change. This one, tractive power. So tractive power change is very high at the higher gear, and tractive power change is not at all high, almost flat, almost constant at the lower gear. That means while you are changing the gears, if you are in the higher gear region, little bit of change in the gear, you have to spend a lot of power for acceleration. So this is the meaning of this graph. I'll repeat again. Whenever you are at the higher gear side, that means in the initial part, x is equal to 2, 3, 4. If you want to accelerate little bit, you have to use a lot of power, because you are finding that slope of this graph. What is this graph? this graph is nothing but dpt dvb. Dpt dvb means with respect to base speed how the vehicle output power is changing. So here you are finding that in the left side base speed is quite high, in the right side base speed is quite low. So in the left hand side where the gear ratio is a higher gear is there, or x value is little less. In this case, if you want to accelerate the vehicle, you have to input quite a lot of power. So too much power it will be requiring to accelerate the vehicle when you are at higher gears compared to the lower gears. Whenever you are at lower gear, at the time doing acceleration may be done effortlessly with lesser power. But with higher gear, acceleration, increment in the acceleration, it will be requiring huge amount of power. This is what is meant here. Next slide is explaining the same thing in a better way. Again, the same graph is shown here. You can find out there are two y-axis, tractive power, kW. So this upper graph is tractive power. Here you are finding that whenever you are in higher gear region or lower value of x is the speed ratio, or maximum speed by base speed, this ratio. So whenever you are at the higher gear side or lower speed ratio, you are finding that changing little bit of change in the speed, okay, or little bit of change in the acceleration will ask more amount of power. Here you are also finding that dpt dvb, whenever you are in the higher gear side, it is asking for more power. Wherever in the lower gear side, here also lower gear side, change in acceleration happens very smoothly without spending much of power. So the same thing whichever was written below to this diagram in the previous slide, again written here, I will repeat. Higher the base speed means you are in the lower gear. Okay, whenever you are in the lower gear, x value is high. So higher the base speed, x value is high, lower is the base speed. High speed ratio means lower gear. High speed ratio means lower gear. That means you are in the right side of this graph. In above diagram, speed ratio of 10 occurs for the lowest gear at this point, and speed ratio 2 occurs at the highest gears, that is in the left side. It's called as a low torque. X cannot be negative or 0. What is the significance of this graph? You can see here 2 points are marked. So this is the first point I have already explained. It means that for higher gears, that means you are in the lower speed ratio range, for higher gears, to accelerate the vehicle, more power is fetched from the battery or propulsion system. That means if you are at higher gear side, in that case, for changing acceleration or for changing speed from one speed to another, you are actually pressing or you are actually pressurizing the battery more. So this is the region. It means that for higher gears, because slope of the graph is more, you can find here slope of this graph also is more. So more tractive power is fetched from the battery whenever you are at higher gear side, because high gear means low torque, higher speed. So for higher speed change in high gears, you are actually trying to exhaust the battery more. So this is a very important thing. So whenever you are on highway, you are driving very fast, then if you are trying to change the speed further, you are actually taxing the battery more. So it means that for higher gears, to accelerate the vehicle, more power is fetched from the battery or propulsion source compared to the lower gear. Lower gear means higher value of x, high torque is already there, so you won't have to fetch more power from the battery because torque is already high. So this is the gist of this third parameter, which is called as a vehicle performance. There were three performances. One was speed, another was gradability, and one was speed, another was gradability, third one was acceleration. So in the acceleration part, we are trying to find out in which case, that is whether the lower gear case or a higher gear case, whether for gear 1 or gear 3, in which case the battery will be pressurized more. So this graph says that whenever we are at higher gear, more power will be fetched from the battery at a higher rate, but whenever we are at lower gear, in that case the battery will not be pressurized more, in that case much easily, and with lower power we can accelerate. So at lower gears, so this is a gist, this is the crux of the third point. At lower gear or at higher speed ratio, you are at the right side, to accelerate the vehicle for the same amount of acceleration, you can find out this is the change in the acceleration. Here also, for causing this kind of change, more amount of power is required, but whenever you are in the right side, in this case, to accelerate the vehicle for same amount of acceleration, much less amount of power is fetched from the propulsion source, which is nothing but battery. So higher speed ratio means lower gear. It saves the power during acceleration. So this last line is important, at higher speed ratio means lower gear. It saves the power during acceleration. So this is the conclusion from the vehicle performance or vehicle acceleration performance for electric vehicle. So two things you have to remember. One is this last line, and second thing you have to remember that whenever we are talking about the tractive power equation in case of electric vehicle, there are two formulas. In the first formula, which is a coarse formula, Pt is equal to delta m by 2t into Vf square plus Vv square. Only the vehicle base speed and vehicle actual speed, Vf, okay. But whenever you want a accurate equation, in that case Pt is equal to this tractive power generated plus loss in the rolling resistance plus loss in the aerodynamic. And rolling resistance is having a factor of 2/3 in case of EV, and a factor of 1/5 is the aerodynamic loss. So this 2/3 and 1/5 is a new factors which is found in case of EV. You don't have to find how is it generated, but only know this much, that the PT formula changes in case of EV compared to IC engine based vehicle. So this completes our lecture number 23 in electric vehicle. We'll meet next with lecture number 24 in the next time. For the time being, thank you all.